You know, we all just expect our apps and websites to work, right? But here's a secret, kind of an uncomfortable one. Every single system out there, it's designed to fail. So today, we're going to dive into this really radical idea in engineering. The secret to making things reliable isn't about stopping failure. It's about planning for it. It's not about being perfect. It's about learning how to make promises, solid guarantees, in a world that's, well, just not reliable.
This is it. This is the bedrock of all reliability engineering. And I really want you to let that sink in for a second. It's not a maybe, it's a certainty. Systems will fail.
So why? Why do they fail? Well, it's for all the reasons you'd probably guess. You've got hardware that just wears out and breaks down, networks, they get flaky, they partition, and then there's us, humans. The people who design and build and run these things, yeah, we make mistakes. It's just part of the deal. Totally unavoidable. Okay, so if we can't stop every single failure, then what? What do we do? This right here is where the whole game changes, the big mindset shift. See, real reliability engineering isn't this losing battle against things breaking. No, it's about accepting that failure is a constant, and then designing systems that can make and keep their promises in spite of it. That's the huge idea we're going to get into. All right, to get there, we've got to redefine what we even mean by reliability, because it's not about perfection. It's about being predictable. Ultimately, it's about trust. So a lot of us, when we hear reliability, we picture 100% uptime, zero errors, basically a perfect system. But that's a total myth. And, it's really important to separate reliability from availability. They sound similar, but they're not. Availability is just asking, hey, is the system up right now? But reliability asks a much deeper question. Is the system doing what it's supposed to do correctly over time? You can totally have a system that's available but completely unreliable, like it's up and running, but it's just spitting out errors really, really fast. The real engineering truth is this. Reliability is the probability that a system keeps its promises. That's it. We're moving away from perfection and towards promises. And we're not talking about vague, hopeful promises here. For an engineering promise to actually mean something, it's got to be three things. It has to be explicit, no room for confusion, it has to be measurable, you got to be able to track it with real data, and it has to be enforceable, meaning if you break the promise, there are actual consequences. So how do we actually write these promises down? Well, engineers have a whole language for this. It's a vocabulary for turning those fuzzy hopes into rock-solid contracts. And this language has a really clear structure, kind of like building blocks. First up, you have the SLI, the service level indicator. This is just what you measure. Let's use an analogy. Think of it as the thermometer in your oven. Next, you've got the SLO, the service level objective. This is your internal goal. For our oven, we want the temperature to stay at 350 degrees. And finally, you have the SLA, the service level agreement. This is the promise you make to your customer. Your pizza will be cooked at 350 degrees. And hey, if it's not, you get a free soda. See, it's that external contract, the one with real-world consequences. And that right there is the key. The SLA isn't just some techie metric on a dashboard. It's a business promise. It's the bridge connecting all that hard engineering work to the commitment you made to your customer. And man, this is where it can all fall apart if you mess it up. If your SLAs are fuzzy, or if your metrics are measuring the wrong thing, like you're watching server CPU when your users are really suffering from slow page loads, then your whole model is broken. Here's the hard truth. If your users are telling you there's a problem before your own alarms go off, your promises are basically meaningless. Okay, I know what you're thinking. This all sounds super strict, right? But here's where it gets really interesting. We're about to talk about one of the most powerful and, honestly, counterintuitive ideas in all of modern engineering. It's the concept that actually gives teams permission to break things, to innovate, and to go fast. It's called the error budget. I mean, this is the classic problem, isn't it? Every time you ship a new feature, every single code change you make, you're taking a risk. You could introduce a bug, cause a failure. So how in the world do you keep innovating without constantly breaking the promises you just made? The answer is the error budget. Let's say your SLO, your reliability target, is 99.9% uptime. Well, what about that other 0.1%? That's not just some leftover scrap, that is your budget. It is the specific, measured, pre-approved amount of failure you are allowed to spend over a certain time. You are literally creating a budget for failure.
And what this does is create this beautiful, simple control system. As long as you have budget left in the bank, you've got a green light. Go fast, innovate, take some risks. This is when teams do things like progressive rollouts, testing new code on just a small group of users. But the moment that budget runs out, boom, red light. All new feature development stops. The team's entire job becomes focusing on reliability, on making the system stronger, until they earn that budget back.
And that's the real genius here. The error budget completely changes the conversation. Suddenly, reliability isn't this scary thing that blocks progress. Instead, it becomes this smart, data-driven dial you can turn. It lets you find the perfect balance between moving fast and staying stable. It gives you the freedom to innovate, right up to the edge of the promises you've made.
At the end of the day, all of these things, SLOs, error budgets, they're just tools. And they're all for one much deeper goal: building trust with your users. And you build that trust with very specific engineering patterns. Things like redundancy, so if one piece fails, another just takes its place. Timeouts and retries, so little network hiccup doesn't bring everything crashing down. And patterns like circuit breakers, which are smart enough to stop sending traffic to a service that's struggling. But if there's one principle to remember, it's this: fail predictably. A failure that's confusing or invisible is so much worse than one that's clear and obvious.
So we've really got to let go of that old myth, the one with the lone engineer, fueled by pizza, saving the day at 3 a.m. That's not reliability. That's a symptom of a fragile system. Real reliability isn't about heroics. It's planned. It's systematic.
And it's also not about this crazy chase for 100% uptime. That's a goal that burns out your teams and costs a fortune, often for a level of perfection your users might not even need or notice. It's all about making smart, deliberate trade-offs. This is what it all boils down to. The entire discipline is about one thing. You make clear, measurable promises to your users, and then you build everything, your processes, your culture, your tech, around keeping those promises consistently, day in and day out. So if you take one thing away from this, let it be this: trust doesn't just happen by accident. It isn't magic. It is the direct result of a disciplined engineering process. When you make clear promises and you build the systems to keep them, you are literally engineering trust.